Well, now that we've spent some time learning how to combine like terms and distribute and that sort of thing, we're going to spend a little while just practicing those sorts of things. So you remember that in the last section when we were talking about distributing and simplifying, we actually covered all of the ideas. And because we simplify so often and we use the distributive property and collect like terms so much, this really is the key to doing these. So we're going to distribute to get rid of parentheses. So if there's any distribution to take care of, we're going to do that. We're going to collect like terms once we're done with that, and then we're just going to make sure that they're written in the correct order. So the notes for today are actually part of the worksheet. So we've got a worksheet here with about 27 problems on it, and I've identified a few that we're going to go through, and we're going to do these together, and then hopefully you'll be in good shape. We'll do the same thing tomorrow. We're going to spend 2 days just simplifying. So when mathematicians talk about simplifying, we want to write things as simply as we possibly can. So let's take a look at number 4. This is not written as simply as we can. You'll notice that we've got a 3x on the outside. We've got that implied multiplication right there. And then we've got 2x minus 5. These are not like terms. They can't be combined in here, so that's not going to help simplify it. But we can distribute to get rid of the parentheses. That's going to make things a little bit easier to deal with many times. So we're going to multiply the two of these together. And again, I'm going to write this out once on these. I did it a couple times in the previous section, but then we're going to write down, I'm going to write down a plus 3x because that's what that is, and then times the negative 5. So when we're distributing through, we're literally taking this term, this number, whatever it is on the outside, and we're taking it and we're distributing that multiplication over and having it take its turn getting multiplied with each one of those. So this is what we have here for this one and what we have over here. So let's just simplify this. We have 3 times 2, that's going to be 6, and the simplest way to write x times x, since we've got two x's multiplied together, would be x squared. When we multiply here, we've got a positive 3 times a negative 5. So that's going to be negative 15, and we're multiplying by an x, so this is it right here. Now sometimes people have different questions about, hey, why does this work out to just have an x? Why don't we multiply the 3 with the 5 and the x with the 5? If you have questions like that, make sure you come up as we're working on these, and we'll make sure that we get those straightened out. This is the correct way to distribute through, and then you'll notice that we don't have any like terms because although they have the same variable, they don't have the same exponent. So we're good to go right there. That is the answer. So let's take a look at this one. This one's a little bit different. We're going to distribute through here. Negative 8x times y, that's negative 8. The number in front here would be a 1, so we still have a negative 8. And then we've got an x times a y. That's it, literally. Done with that part. Now we distribute through here. You'll notice we have a negative times a negative, so that's going to be a positive. 8 times 4 is 32. And then we're still multiplying by an x, so we put that implied multiplication with the x there. And that's it. You'll notice this fits with our pattern of writing the one with more variables at the beginning. If we've got x's, y's, z's, and that sort of thing. So that one's just fine the way that one's written. This one's a little weird having the 2 on the end, but we can deal with that. We'll go ahead and distribute through. 2 times 2x is going to be 4x, and 2 times 5 is going to be 10. Done. That's it. So 3 problems done just like that. So let's take a look at another one, and this is I've got a double asterisk by this one. This one's really important. There are times where people will look at this, and this comes up all the time, so please try not to make this mistake. They'll look at this and they'll say, oh, this stuff comes first, I'm going to go ahead and try and subtract these. So they'll do something weird, like they'll do 7a minus the 7 would just be an a, or something strange like that. If you stop and think about how we combine like terms, that wouldn't work anyway because these don't have the same variables. This one has an a on it. This has, I mean, if we wanted to get technical, this has all of that stuff right there. Besides that, if we think about the order of operations, we do parentheses first. Try and combine the stuff in parentheses. Can't do that. There aren't any exponents here. Then we do multiplication and division in the order we come to them, and then addition and subtraction. So this is implied multiplication. We're going to do that first. So I'm going to write 7a. When we do negative 7 times 4a, that's going to be negative 28a. Negative 7 times positive 2, so that's going to be negative 14. Then we go through and collect like terms and write them in the correct order. These are like terms. I've got a positive 7a minus 28a, so that's going to be negative 21a. It's kind of like if I have 7 apples and owe somebody 28 apples. If I pay them the 7 apples, I still owe them 21 apples. And then the minus 14 goes on the end. The constant goes on the end. All right, let's take a look at this one. This one's also kind of interesting. This is x minus this stuff in parentheses. And remember, we talked about this before. You can think of this a couple different ways. You can think of this as a -1 and then distribute the -1 through, or you can just remember that negative means opposite. So we're going to have x and then minus each one of these, or the opposite of each one of these. So this would be a -5x, and this is going to be a +9. And you'll notice that this works with multiplication as well. Negative times a positive is negative. Negative times a negative is positive. So there we go with that. We'll go ahead and combine like terms. We've got some like terms there with the x's, so minus 4x and then +9. Circle that and we are done. Slide down and do a couple more of these. Let's see what we've got here. We've got 3 more we want to take a look at. We want to take a look at number 19, number 22, and then number 26. So here's number 19. You'll notice that there's no distributing to do. There are no parentheses. All we have to do is collect like terms. So there are some like terms. Let's put those together. If I have 9 of these things right here and another 3 of those same things, I have 12 of those. Okay, so 12x squared. It doesn't become x to the 4th or anything weird like that. Again, if you need to use a name for these, we could say oranges. 9 oranges plus 3 oranges is 12 oranges. And you'll notice that because this is x squared, I couldn't call those oranges. I'd need to come up with a different name. So we could say we've got 5 apples minus 7 apples, so that would be -2 apples. In descending order, all set to go there. Let's take a look at this one. We're going to distribute through. Remember doing these before. 3x times 2x. 3 times 2, we can take care of that. That's 6. Easiest way to write x times x is x squared. 3x times -5. Positive times a negative is negative, so that's going to be -15 with an x there. And then, whoops, plus 4x squared. Whoops, need that exponent on there. So if I combine these, let's see, we get 10x squared minus 15x. Running out of a little space there, but there's the answer on that one. And then the last one here, no parentheses, so no distributing to do. We're just going to collect like terms. Got some x squareds there, so 5 of them minus 3 of them, that would be 2 of them. And I've got some x's, 5 of them minus 9 of them, that's going to be -4 of them. And that's it. Descending order, we're all set to go. So as you're going through and doing these problems, if you have any questions, please make sure you ask. Let's make sure that we get this straight. This is you're going to be doing a lot of simplifying as the years go by and as this course goes by. So you want to make sure that you understand how to do this really well. So good luck with the assignment, part 1. Thanks.